Welcome everyone. We got through part of this problem in class for some classes, and some of us we got all the way through. So depending upon where you are, maybe you want to fast forward or rewind. But this is off the worksheet called In Class Problem Number 8. So these are the Fab 5 equations we're going to be using, and here is problem number 8. So in problem number 8, they are going through, and it's an apple falls 3 meters out of a tree and it lands on Sir Isaac Newton. How fast was the apple going when it hit him in the head? And the idea, again, is we only look at part 1 of the question. We don't look at part 2 yet. Okay, so in order to do this, we're looking for key things. We're looking for numbers, 3 meters, and we're looking for questions. How fast was it going? Okay, so that's what we have. Just for the record, this is not a number for the problem. That's the answer for the problem. Just keep that in mind. So we're kind of done. We have an apple. Pictures are good. Sometimes we have an apple that's a terrible apple, but the idea is it's going to fall and it's going to hit Newton in the head. Okay, and the distance from here to here is 3 meters. That's all we really know. So we can go through and we can say, we can make a list, but we should really kind of stop and identify problem types. So this is what we talked about in class. These are the problem types. So we go through and we look at, is it a 1D motion problem? Is it only moving in the X or the Y direction? And the answer to that is yes. That is a yes. It's a 1D motion problem. Then we have to make the choice, is it in the X column or the Y column? Is it moving vertically or horizontally? And it's moving vertically. So that's the list of variables we're going to want. So we get delta X, VI, VF, A, and T. So we're going to go through and we're going to make our list because it's a 1D motion problem for the Y column. So we knew it was that type. Then we go through and we ask, is it a constant velocity problem? Is the velocity staying the same throughout? Is the acceleration 0? Does it say there's not accelerating? And the answer to that is no. It's falling through the air. It was stationary. It was in the tree, and now it's falling, right? So no. So now we're down to the third point. Is it a free fall problem? Is the only force acting on the object gravity? So an apple falls from a tree and it falls to the ground. Is the only force acting on that apple gravity? The answer is yes. So because of that, we can then fill that in. It's an acceleration due to gravity, and on Earth, keep in mind the negative tells me the direction. So then over here, we can say that my acceleration is negative g, which is equal to negative 9.8 meters per second squared. Okay, and then the last problem, does it say that the object is dropped or falls? And the answer is yeah, right? It says it falls out of the tree. So because of that, yes, we can say that our initial velocity of that apple is 0. So my initial velocity of my apple is 0 meters per second. That's stuff we can get from the problem types. Those are numbers we can get from the problem types. So now we can go into the problem and we can say, well, what information can we gather from the problem? We could look at the how fast was it going? That's my question mark. When it hit him in the head, so that's that. It is not 0. Okay, do not tell me 0. I'm not looking for 0. I'm asking how fast was it going right before it hit the ground? Not 0. That's my question mark. And then this last piece, and again, from here to here is 3 meters. But remember, displacement, velocity, and acceleration are vectors, so we need directions associated with them. We need directions associated with them. So is this object in the y direction? Is it going up, or is this object going down? Is it a positive or is it a negative? Well, the apple falls downwards, it's going downwards, it's going to be a negative. So this is a negative 3 meters is my displacement. That's important that we get the negative because that tells me the direction is going to be downwards. Now we can go through and we can say, well, I don't know time and I don't care about time, so let's pick an equation that doesn't have time in it. So if we look and say, what equation doesn't have time? Equation number 4, there is no time. So equation number 4, VF squared is equal to VI squared plus 2 times A times delta Y. Notice how I use delta Y instead of the delta X, delta Y. Our initial velocity was 0, so 0 squared is 0. So then we can say, well, my final velocity squared is equal to 2 times negative 9.8 meters per second squared times a negative 3. My final velocity squared is equal to 2 times 9.8, negative 9.8 times negative 3. So negative times a negative is positive. That's going to give us a positive 58.8. Now we need to go through and we take the square root of both sides, and my final velocity is equal to 7.668. And I'll add a units in a second because I want to talk quickly. Square root of 4 is plus or minus 2, right? Because negative 2 squared equals 4, and positive 2 squared is equal to 4, so we say plus or minus. Now the reason I'm drawing your attention to that is the correct mathematical answer is it's plus or minus 7.668. Now what we need to do, anytime we have an answer that is plus or minus, we have to make some choices. Now we have to say, is this object going down? Oops, that's not what I meant to do with my pen. Is my object going down or is it going up? Is my object moving in the negative velocity or is it moving in the positive direction as it hits Newton in the head? And I hope you recognize that's going to be the negative. So based on that, we make the choice that my final velocity is negative 7.67 meters per second. And that's my final answer for part A. Now, again, I talked about this in the last in-class video. The best choice of solving a two-part problem is to go through and say, well, now we want to find out this. The best approach would be to pretend like we didn't just solve for that and not use it if at all possible. That's the best approach. So now we can say, well, what equation doesn't have a final velocity in it? And we could say, well, equation number 3 doesn't have a final velocity. So equation number 3 is delta y is equal to vi times t plus 1/2 at squared. My initial velocity is 0, so 0 times t is 0. So then we are left with my negative 3 is equal to 1/2 of negative 9.8 times my t squared. So negative 3 is equal to negative 4.9 t squared. That's 1/2 of negative 9.8. Then we go through and we divide both sides by negative 4.9, divide by negative 4.9, and then we get a value of 0.6122, which is equal to t squared. Now there's actually more digits there, and I'm going to use all those digits in my calculator. But the idea is then when we take the square root and we take the square root, our t is going to be plus or minus, right? Plus or minus. But we can go through and say it's going to be plus or minus 0.782 seconds, plus or minus. But time is not a vector quantity. So because time is not vector, we don't need to worry about whether it's positive or negative time. We can just say that our time is equal to 7.8 seconds. Oops, wrong button. We can say that that's our final time. There's one more problem that we'll kind of work through. If you have any questions, let me know.